All right, so guys, we've been talking a lot about this proportion stuff right here in terms of similar figures. That's not going to go away like you said. So 8.6 is titled Proportionality Theorems. Okay. And this essential question that we're looking at answering today is the following. We're going to say, what proportionality relationships exist in a triangle intersected by an angle bisector? Kids, help me out. What's this word mean? Cut something in half. Or by a line parallel to one of the sides. So again, let me read that. What proportionality relationships exist in a triangle intersected by an angle bisector or by a line parallel to one of the sides? Okay, I'm going to highlight a word here because, again, what's not going to go away? Proportionality. We're going to be setting up equal ratios a lot here, okay? So our goals to answer this question for the day are the following, okay? First goal says I can use proportionality theorems. Right? That shouldn't be a problem. And then one that's going to get a little bit tougher, I think, is going to be I can partition directed line segments. So we need to understand what some directed line segments are. Okay, so that's the first vocab term. And the first vocab term that I'm at right here is directed line segment. It says a directed line segment, AB, is a segment that represents moving from point A to what? So as an example right here, when we talk about making sure that this is a directed line segment, okay, if I put this as A and put this as B, I would call this segment AB, which really means to start at what point, kids? What's listed first in that? Start at A and at what? Yeah. Okay. So a directed line segment, AB. Start at A, end at B, okay? What if I have directed line segment GH? Start where? End at H, okay? So we're kind of talking about some kind of direction right here. Where are you going? Okay? All right. Well, let's take a look at this right here then, kids. So the next part then will be talking about corresponding angles. You guys know a lot about corresponding angles. If I read this definition, we'll do an example here, but it says corresponding angles are angles in the same relative position of a similar figure. You guys have looked at a lot of that. I don't think I need to talk about that, but I also want to just mention to you guys that if I say something like this, if I say triangle ABC, is similar to triangle UHS, okay? What angle is listed first in the first triangle? A. Which matches what here? U. So A and U would be in the same relative position. Okay, we know that corresponding angles are equal. So by this right here, the way I've written these two similar statements, I could say A is equal to what, kids? B has to equal what? H. And C would have to equal what? Okay. Those would all be the angles that are in the same relative position, and all those angles that match up would be congruent. Okay, so you know that already. All right, guys, ratios. I don't think I need to deep into this here, but it says it's a comparison of two units in what? Fraction form. Okay, a ratio is just a comparison of two units. You know you're probably setting up a what? Ratio is just a fraction. And then you know proportions, two equal ratios that we use cross multiplication to solve. I don't care about what the answer here. Just make sure we're good here. Kids, I don't care about the answer. Give me process. How would you solve that? What two numbers would you multiply first? 7 times 28, and then you would turn around and divide by what to solve that? 63. So that's our proportion. We use cross multiplication, division to solve, and that's going to be the way that we solve a lot of these problems. Okay? Guys, as far as vocab goes right now, are we okay? Yeah? All right. Let's take a look at this first core concept here today. All right? First core concept is titled Triangle Proportionality Theorem. All right? Let's see if we can't make sense of this. On the left, it says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So for instance, right here, kids, it says in this situation right here, you guys see lines TU and QS right here? They are what? TU and QS are what? They're parallel, aren't they? Okay. Then it says right here the ratio of RT. Okay. So basically it says right here, if I called this a distance A and a distance B, it says RT over TQ. So the way I've labeled it, that distance A over B. And if I label this C and a D, C represents RU and D represents SU, that's got to equal the distance from RU over what, kids? Okay, and I'll just use the variable C over what? Okay, so guys, it's kind of like saying this. Look at this top side. If you got a triangle, and inside that triangle, you've got a segment that's parallel to the base, maybe. They're simply saying right here, this length A to B is the same as the ratio C to what? D. And that only occurs if these two lines are what kind of lines here, kids? Parallel. They have to be parallel in order for that to be true. Okay? Now, the converse of that is true, kids. If I say this right here, if I call this A over B, or A and B, I'm sorry, if I label RTA and TQ a distance B, if I call RU a distance C again, and if I call it distance U to SD, this is saying the following, kids. It says if A over B equals C over D, then this would imply that the lines TU, or the segment TU, I should say, would be parallel to what? What would TU be parallel to if that was a QS? Very good. Okay. All right. So, guys, basically, you're just saying a fraction, okay? One side or one segment to the other segment on the same side is equal to the same of one segment to the other segment here. So, A is to B as C is to what here, kids? A is to B as if these are what types of lines? Parallel. Okay, keep that in mind. In fact, let's put this into action here. Do you guys have everything first page so far? Okay, let's take a look at some of these problems here. Kids, go to example 2. I've got a little typo here first. Go to example 2. Do you see right here? See where it says is not parallel? Cross out the word not right there. Okay. Cross out the word not right there. We'll come back to that here. Once you've got that crossed off, jump up to example 1, my friends. Okay, example 1, finding the length of a segment here. It says in the following diagram, WZ is parallel to XY. Do you see my two parallel sides there, friends? Okay, it says WX is 12. They've labeled that for us here. Okay, they say V to Z is what? And Z to Y is what? Okay, what length are we trying to find? We don't know what V to W is. And since that's unknown, I'm probably just going to call that a distance X right here. Okay? So, guys, I could say the following right here. I could say X is to what? 12 as 10 is to 8. Yeah. By that theorem that we looked at on the first page that was called triangle proportionality theorem, we can simply say in this right here, X is to 12 as what? Okay, when you cross multiply and divide, somebody want to tell me what you have there? Anybody punch that up yet? 15, is that what I heard? Okay, thank you, Garrett. Okay, so that distance X is 15. What segment does that X represent, kids? Yeah, the length of V to W has to equal that 15 right there. Okay, simple. Again, what do we have to set up to try and solve these? Starts with a P. Proportions, okay, just not going to go away, all right? Okay, so let's use that idea in a real-life problem. It says on the shoe rack shown, okay, BA is 35 centimeters, CB is 25 centimeters, CD is 20 centimeters, and DE is 28 centimeters. Explain why the shelf is parallel to the floor. Well, kids, I'm going to look at a cross section of this. I'm going to look at just the side right here. Okay. They are saying we have a triangle. It looks kind of like this. And they want to say, now, does this, the way they've drawn it, look like it's even parallel? It doesn't, does it? Okay. It doesn't even look parallel at all. All right. But they're saying, given the dimensions in example 2, that those two parts should be what? Parallel, okay? Basically, we need to try and show, that segment BD is parallel to segment what, kids? AE, is that what I heard? All right, okay, so I'm going to draw a triangle here. I'm going to do the best I can. I'll draw a cross section. Now, again, they're assuming that this is parallel, aren't they? And I'm going to label this the way that they've got this up here. So I'm going to call this ABC on the left, D and E here. All right. Once you've got that down, you guys help me dimension this out here. Kids, what's the first distance we know? BA is what? 35. And this is going to be a little out of scale, but don't worry about it, okay? What else do we know? C to B is what? 25. What other sides do we know? 20. And DE is what? Okay. They want us to prove that the segment from B to D and the segment from A to E are parallel. Here's how I'm going to do that, kids. Take a look at the left side of the triangle. What ratio could I set up? What over what? Okay, so we're going to say, look at the segment from 25 over 35. Okay, that's one segment we're going to look at. What other, I should say ratio. What other ratio are we going to look at? 20 over 28. Okay, I just like to turn these to decimals. We could simplify them as fractions, but somebody punched 25 over 35. Might be kind of an ugly decimal. Let's go 3 places with it. What do you get when you go 25 divide 35? 714. Okay. How about 20 over 28, my friends? Ooh, are these the same or are they different, kids? So if these ratios are the same that we looked at, what's that imply about BD and AE? They have to be what kind of lines? They have to be parallel. So here's how I'm going to write this as a solution. Here's what I'm going to say. Okay. Guys, do you agree that 25 represented CD right here and 35 represented BA? Would you agree with that? Okay, so I'm going to say since the ratio of segment CB over BA was equal to, what do I want to put in the second ratio, kids? Since CB over BA was equal to, go to the right side, CD over DE, that was a 20 over 28 part, right? What must we say about segments BD and AE then? BD must be parallel to what? AE. Very good, guys. Very good. Okay, so if those ratios, when we're comparing the segments on one side, that ratio on one side of the triangles is equal to the ratio of the segment comparison on the other side, then that implies the two lines that might be parallel indeed are what? They are parallel. Okay? So I think this is a pretty good example right here. I think this would be something that you might want to come back and revisit here. I'm just going to highlight that. And I'm actually going to put a little star by this problem because I think it's important. Okay? I think that's an important one. Guys, talk to me. What questions do you have about that right there? Again, isn't everything about comparing ratios right now, my friends, in this section? All you are doing is comparing what? Ratios. You're setting up proportions. You're comparing ratios, okay? Fraction to fraction, fraction to fraction. If you can remember that stuff in this chapter, you're going to be pretty successful. Okay. Well, let's move on here, kids. Another core concept. Ooh, not two parallel lines. We're gonna live dangerously and go. Oh, three parallel lines. Anybody scared yet? Three parallel lines is vecna scary. Okay. If three parallel lines intersect two transversals, then they divide the transversals proportionally. Okay, here's the deal. Can you guys identify the three parallel lines in the examples they give here? Whoops, I didn't want to do that. This is what I wanted to do. Aren't these my three parallel lines right here, kids? R, S, and T. You guys see them? Okay. They're saying the following, okay? How many transversals are running through those parallel lines? Two of them, L and M, right? Okay. They simply say if this is the case, if you've got parallel lines that are cut by multiple transversals, you see this segment UW right here? They would say UW up top over the segment VX is equal to what? I don't like the way they do this. No, I'm sorry. I've got that wrong. UW to what? Okay, so right up here, this segment to this segment, WI, that's this first one, would equal VX over what? X to Z right here, okay? So you're going this to this is the same as this to this, all right? So guys, just take a look at this diagram. There's a diagram that maybe explains it better, okay? You guys see your three parallel streets up there? Looks like Main Street, 2nd Street, and South Main Street. These are my parallel streets, aren't they? Everybody agree with that? They're saying H to G right here. HG over what, kids? FG, that's this one, would have to equal CD over what? DE. And that's under the that's under the condition that these are what type of lines right here, kids? They have to be parallel. Okay? All right, so let's take a look at this and try and see what we can come up with, all right? Everybody with me on that? Okay. Boys, make sure we're listening. All right, here we go. This is a kind of tricky one, okay? Guys, it says in the diagram, angle ADE, angle BEF, and CFG are all congruent. Okay, all these angles up here are congruent. So what's going to be true about these three diagonal lines, kids? They're going to be parallel. So I'm just going to mark down if those angles are like that, these have to be parallel lines, okay? These are all corresponding angles, okay? Here's the deal. They tell you that AB is how long, kids? 30. What's BC? DE is how much? 35. We've got to find the distance from D to F. Okay, we've got to find the distance from D to F. Kids, I can't find the distance from D to F until we figure out E to F, right? Don't you know E to F to figure out what D to F is? So I'm going to jump in here. I'm going to draw a little arrow here to this little segment right here. I'm going to call that an X right there, okay? Guys, based on that parallel line proportionality theorem, I could compare 35 to what? 35 is to X, as, give me another one that we could use, is to, did I hear 12, kiddos? Okay, 30 is to 12. All right, I don't have a calculator in front of me, my friends. Actually, I do. I lied. Here. What would I multiply and divide, kids? 35 times 12? Divide by what? What do we get? 14. Okay, so X is 14. Now, kids, read the question. What are we trying to accomplish here? We're trying to find the length from where to where? Okay, so is there enough information now to know that segment length from D to F? What are you going to do? How much there, Jewel? Okay, so solution-wise, here's what we're looking at, kids. We would say solution. DF would equal that distance. 35 plus what? Okay, too bad that doesn't say 43 plus 24. But hey, who am I? Anybody watch the Duke and Florida game last night? Duke won 67-64. Anybody watch North Carolina and Kentucky? Winner of that game had 67 points also. And Iowa came back down to reality last night, playing a good team. Michigan State is legit, aren't they? Woo! Our 8th grade girls won last night. In overtime. Barn burner. Jessup. 15-12. Oh, it was painful, guys. It was 10-10. It was 10-10 going into the 4 seconds to go, you know. And so our coach that's down there, she's new, okay, and so she's learning. And we got the ball with 4 seconds to go under our basket. She took a timeout. She's like, "What do we do?" I think you should draw a play up for him and try and win. She said, "I don't know what to draw." She said, "Give me the board." I drew a play up. I drew a beautiful play up. It was the best play ever, okay? Going to free Avery Folk up on the opposite block. We ran a double screen and looped her around. Guess what? Avery comes wide open. I mean, like, see where Jewel's standing? And the basket's kind of that table right there. And then the defense is all of those boys over there. That's how well the play worked. That's how wide open she was. She missed the shot and felt so bad, but we ran the perfect play. But then we won in overtime, so it was great. It was good. All right. I felt good for them. They lost to Jessup the first time and then turn around and do what the second time? Beat them. That's a good thing, right? Okay. All right. Hey, we better get back on to math, right? How did I get sidetracked here? Oh, I was talking about 67 points in basketball, wasn't I? Then basketball got in. All right. Hey, are you guys okay with setting up ratios involving parallel lines? That's my first question. Yeah? Okay. All right. Let's talk about this core concept then here. Now, the next one here is a little trickier here, okay? I'm not going to get too concerned about this diagram over here, but what I want you to do, guys, is call that distance from Q to R, call that a 15 minus X right here before we talk about this, all right? All right. Kids, here we go. This says core concept of the triangle bisector theorem. It says if a ray bisects, again, remind me what bisect means. Cut something in half. Yeah, so if I have a 40-degree angle, that would get bisected into two 20-degree angles, okay? The theorem says the following. If a ray bisects an angle, okay, so here's a ray cutting angle C into two equal angles. Ray CD cuts that into two equal angles. If that ray divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides, that's kind of confusing. Okay, I'm gonna put some stuff in here. Okay, I'm gonna put an X and a Y right here. Okay, and I'm gonna put an A and a B right here. All right. What this is saying, guys, is this. This is saying the ratio of the side it divides. In other words, A to B. That ratio will be the same as X over what here, kids? Y. Okay, you can look at all the segment notation here, but the way I label it, all this is saying is the distance from A to B would equal the ratio of X to what? Okay, B or X over Y, isn't it? Okay. All right, so here's an example down here. Let's go down to example 4. Okay. It says in the diagram, BACD is congruent to what, kids? Okay, basically, kids, doesn't this ray, A to C, give us two equal angles right down here? So isn't that bisected? Okay, it says we've got to find the length of what here, kids? CD is defined by what variable as a distance? Okay, so guys, this is simply saying the following. You can go 18 over what here, kids? Okay, the way that this theorem reads, you'd say 18 is to Y as what to what? 42 is to. Okay. Who's got a calculator to cross multiply divide for me? Yeah, Y is 27. Okay, so the question said find the length of CD. So my solution down here, we would say, well, by our work rate here, CD has to equal 27 units there. Okay. All right, guys, we're going to give you about 3 minutes and 14 seconds here on the next page. I'm going to have about 4 problems I want you to do to try and make sure you understand before we walk out of here today. Any questions up through example 4? Okay, is there a part that says on your own on the next page, kiddos? Okay. Take about, 3-4 minutes. What have I done? Take about 3 or 4 minutes right here, kids. And here's what I want you to do. Okay, the on your own part right there, go ahead and work yourself through those. And then once you have an answer to that stuff, compare with somebody, and then call in some people here to help me out with those 4. So go ahead and see what you can accomplish there. Guys, in that first one, it says find the length of the given segment. You know you're looking for BD there, right? And all these you're going to have to set up a what? You're going to have to set a proportion up, you bet. Stranger Things. I traveled to the upside down. You want to see me travel to the upside down?
With it.
What if the upside down is really the right side up in that show?
You need to quit watching this.
I do, but I don't understand how the upside down works because gravity and that stuff starts getting into my brain. It's like, how does the upside down work? What happened to the gravity?
Has Lucy Texas?
I think their flight leaves at 10 o'clock today.
Is it just her and
Her and King along.
yeah?
And then Mom and then Mary went. So there's 4 of them that went.
What if she's swimming Ruby? Is she swimming a lot?
Ruby will say, Dad, I want steak or supper. Yeah, let's go. She starts that Thursday, Friday, Saturday. I think still 20 hours left on Sunday. I want to say, I can't remember if this is true or not, but Kate Douglas is down there. I think she might be in it. She's going to get smoked.
Oh my god.
I'm excited for her though, because Louisville is bringing some of their collegiate kids to it. She's going to get to be with some of her college coaches that are down there for a while, so get a chance to learn some more stuff. So I'm excited for her. I think that'll be a good thing for her. Yeah, bud. Yeah. This to this first. Oh yeah. Okay. So switch those 2 around in a second. Okay. Then do your work. Okay. Thank you. You guys tell me, what time do we get out? 39, is that right? If we start looking at these by 35, did that give you enough time? We're going to end with these anyway today, so there won't be an assignment. I hear it's supposed to get kind of cold tonight. Is that true?
Yeah.
Is there supposed to be wind with this or not?
I don't know.
Wind chill stuff?
Mr. Clark said about every 2 hours.
Really?
Yeah, because this is too negative.
I heard there's supposed to be record-setting lows tonight.
Yeah,
So. It's been a weird start to winter already.
We still have 5 days to go.
Yeah, we'll be all right, I think.
Unless we get a blizzard.
It's possible. Anything's
Monday
possible.
starts on Monday.
To be honest with you, it's like the months of February and March have been the ones that have been kind of the rough months here in the past few years.
Hopefully, now that like we're getting along December, it's
Yeah. Okay, guys, let's talk on this first one. What length am I looking for here? Okay, these first two are parallel line theorems, aren't they? So we're trying to find the distance from B to D, aren't we? You know what it says? I don't know what B to D is, so I'm just going to put an X down here. Kids, what ratios or what proportion did you set up? 16 is to 40 as X is to 30. Now, some of you may have switched that around and gone 40 is to 16 as 30 is to X. Same thing. Kids, when you solve that, what do you get for a solution? Yep, BD is 12. Okay. How many had 12 for that? Very good. Very good. Okay, how about what are we looking for in the next one here, kids? J to M, right? So what's the proportion, kids? I'll use yours, Holden. You went X over 16, so you kind of worked right to left. So if he works X over 16, what's he going to have for a second ratio? 18 over 15. I can't remember what this was. I think it was like 19.2. Is that right? Okay, how many had 19.2 for that? Okay, questions on those first two at all, kids? Feeling good? Okay, let's go to the angle bisector one then, kids. Find the value of the variable. So we're looking for X down here. How about a proportion, Kenny? Yep. How many agree with Kenny's proportion here? Given that angle bisector. Absolutely. Kenny, what'd you get for a solution? Good. Okay. Guys, this next one's a little trickier. They threw a funny distance at us, 4 root 2. Guys, would you agree that this is 4 over 4? Has to equal 4 root 2 over what? Y. Now, maybe you turned it to a decimal. I don't know. But kids, I have a question. If I have one thing over the same thing on the left, wouldn't that reduce to what on the left? So I'm going to have one thing over the same thing on the right to get a reduced ratio of 1. So how could I write y in simplest radical form? What would y have to equal here? 4 root 2. Anybody turn that into a decimal like 5.66? Anybody have that in decimal form? 5.66? Did you do that way too? Okay. If you do, it's approximately 5.66 there. Kids, just give me a show of hands. How you feeling about those? Thumbs up, thumbs down? All right. We've got one more to finish up here tomorrow.